Good day, student. You're welcome to today's lecture. Today's class, we will be looking at the chapter 3 of our syllabus for the cost accounting, and the topic we'll be looking at is known as cost element. Is known as cost element or element of cost. If you remember our discussion under the cost classifications in chapter 2, we looked at a particular classification known as classification by nature. So we're going to buttress that particular topic, which we will be discussing under the cost element. Now, according to nature, cost can be classified by nature. Cost can be classified into materials, labor, and overhead. Cost can be classified into material cost, labor cost, and overhead cost. So these are the fundamental elements that we'll be looking at. So we will be discussing the material cost, the labor cost, and the overhead cost or expenses. But to avoid the tautology of saying expenses cost, we therefore make use of overhead cost. So these are the cost element. These are cost element. So we'll take this one after the other. Now, the first one is the material costing. So we'll be discussing the different parts of materials, classification of materials, the control of materials, the various systems relating to material controls, as well as how materials can be priced. The term material is generally used in manufacturing concerns, and this refers to raw materials that are used for production, sub-assemblies, and fabricated parts. The term materials and stores are sometimes used interchangeably. Material cost constitutes a prime part of the total cost of a production of manufacturing firm. And therefore the proper accounting is required for controlling material through purchase control, stock control, issue control, control over various losses. Material control basically aims at efficient purchasing of materials, storage, and efficient use or consumptions. So in order to assist an organization in monitoring and planning the cost of production, because basically we are going to emphasize manufacturing organization as they are organization that material is a core component of their cost. To a restaurant, they need to be able to monitor the materials such as the rice, the various spices, and other ingredients. To organizations such as beverage, those engaged in beverage, they need to monitor their sugar, they need to monitor their milk, they need to monitor their choco or cocoa, and what have you. So material cannot be emphasized for a manufacturing organization because it is the core item they use. Now, the classification of inventories, we can classify inventories as raw materials, work in progress, spare parts or consumables, and finished goods. Remember that raw materials are what all the organizations majorly will use for their production. Some products that are not fully completed in a particular organization may be what another organization would need for its own production. So it could serve as a work in progress. Then we have spare parts and consumables that can be used especially for those in the automobiles and the mechanicals. Then we have finished goods that are equally used. So we are going to take a step further to discuss what we call the inventory control. So how do we control our materials? Inventory control includes the functions of inventory ordering, purchasing, receiving goods into the store, storing and issuing inventory, then controlling the levels of inventory. Now let's bring out what this control is talking about. Making an order as well as buying materials, you need to control, because if you did not control the quantity of materials you want to order, or you do not control the purchase price, it's likely going to result into high cost of purchase or high cost of materials. Then you also have to plan how materials are received into store. There we'll be talking about bin card. We will as well. Now, another thing which an organization would have to control is how materials are issued from the store, issuing of inventory from the store to production. So this will allow them manage their cost of production, determine the cost of materials issued to production, and as well they have to control the levels of inventory so that they will not run out of stock nor have more than the items that a particular store or warehouse can accommodate. So inventory control is one very important aspect of material costing. The following are objectives of material controls. Why we have to control our material? Materials of desired quality should be available when needed for efficient and uninterrupted production. So this can be taken as the keyword for efficient and uninterrupted production. Materials should be purchased only when it is needed and in most economic quantities. So economic quantities, the number of units that is going to minimize the cost of production. Investment in material is maintained at minimum level that is consistent with operating requirement. So objective here is to ensure consistency with the operating requirement. Purchasing of materials will be made at the most favorable prices under the best possible terms. Price is a keyword I can pick here. Material is stored in such a way that the objective of production is met fully, and at the same time material is made available easily. So availability, issues of materials are authorized properly and accounted for. So objective here is to ensure that there is authorization and accounting. Materials at all the time charged as the responsibility of some individuals. So we should ensure that the person who is responsible for monitoring, issuing, purchase, and receiving are charged with the responsibility, and they are ensured, and it is ensured that the responsibility are carried out effectively and in the best interest of the company. So these are some of the objectives of material control. Now let's look at the various control levels. Inventory control is the system used in a firm to control the firm's investment in stock by recording and monitoring of stock levels, forecasting future demands, and deciding when and how many to order. Now, there are three reasons why an organization would need materials or demand for it. Precautionary motive, in this case to avoid stock out, that is running out of stock. Transactionary motive, to ensure there is a smooth flow of production, that materials needed are available as at and when due. So this is for day-to-day activities of production. Speculative motive, to make sure that make future profit by taking advantage of likely increase in future price. So the company can buy more of a commodity now to ensure that at the time the price will increase, they will take the advantage of the increase in price. Or they can as well buy more of a commodity where it is perceived that the supply of that commodity in the future will reduce, or the quantity might be short in supply in the future. So by the time they have more or many of the items in store, then they would not be hit by such shortage of materials. Now we have different types of inventory control system. The various ways inventory are controlled. One, the economic order quantity, which are to do with the quantity to order, the reorder level, when to order, and just in time, how. So I can talk about when, why, and how probably. So let's take this part of the inventory control, starting with the economic order quantity, EOQ. This is a method of stock control that is concerned with minimizing the total controllable cost. The EOQ is a calculated order quantity which minimizes the total ordering and carrying cost, which is the total relevant cost of inventories. It should be noted that the EOQ is the point at which the total carrying cost equates total ordering cost. Now, we can as well say that the economic order quantity is the number of unit or quantity of a material that should be ordered by an organization in order to minimize the cost of materials. So at the EOQ, the company will minimize the cost of its materials, the cost of materials that will be purchased. So if an organization aimed at minimizing or reducing cost of materials, then the organization must establish its economic order quantity. Now, in determining the economic order quantity for a company or an organization, there are four major costs that are associated with the EOQ, and we need to understand the costs that are associated with inventory. There are four major types of costs associated with stock. The first one is the purchase cost. This refers to the actual amount paid in acquiring the stock. So this is what will be paid to an organization for buying an item, and it is based on the price for 1 unit times the quantity to be purchased. Then, we have holding cost or carrying cost. This refers to all costs that will be incurred from the point when the stock or goods get to the warehouse to when they are disposed or sold. So it simply means the cost of keeping the items for safety purpose or for safe custody. Such costs include insurance cost, interest on capital, security cost, rent for the warehouse, maintenance cost, storekeeper salary, etc. So we can say that the holding cost is the cost of keeping the materials in store. Then we have the ordering cost. This is the cost of obtaining stock, such as transportation cost, administration cost, accounting cost, etc. The ordering cost is also known as handling cost. Then we have stock out cost. The stock out cost refers to the cost that will be incurred for being out of stock when there is demand. That is, when the company runs out of inventory, it will be the cost they will incur for such situation. Then the problem or the cost that the organization will have to incur is they are going to lose contribution that could have been earned if demand was successful. They are going to lose some of their customers. They will incur emergency cost of meeting a particular transaction. They will lose face, that is goodwill, and they are going to lose profit. So the effect or the cost of running out of stock is the loss of contribution, loss of customers, emergency cost of meeting transactions, and the loss of goodwill as well as the loss of profit. Now, the loss of contribution and customers are related to the shortage or reduction in patronage. Now, moving on, we have the basic assumptions of EOQ. That is, the various things that we have to understand when we are dealing with the economic order quantity. Demand is constant and known with certainty. So it means that we are expected to know the annual demand. The ordering cost is constant and known with certainty. The holding cost per unit is constant and known with certainty. Purchase price is known and constant. Replenishment is made instantaneously. So these are some of the assumptions of EOQ. Then we have the various methods of deriving EOQ. That's derivation of EOQ. There are two ways we can derive EOQ, three ways majorly, but in cost accounting we emphasized only one. There is the graphical approach. We can derive the EOQ of a company by graphical approach, and this would involve plotting the graph. Now we have the ordering cost going this way, and we have the carrying cost going this way. And from our explanation, we said the economic order quantity is achieved where the ordering cost and carrying cost of a company equate. So at this point, this is the equilibrium position. So at this point, the point A is the equilibrium position. That is the point where the quantity at this level and the cost at this level will be minimal. So the company will minimize cost at this level, and whatever quantity that is here is our EOQ, the reorder quantity or economic order quantity. And from this graph, if we are going to plot the graph for the total relevant cost, at that level, the total relevant cost will be minimal. At that level, total relevant cost will be minimal. This is total relevant cost. Will be minimal. So we can say that the economic order quantity is achieved. The economic order quantity is attained at the point where the equation of the ordering cost and carrying cost intercept. The quantity at this point will be the reorder quantity that will minimize cost of materials. So usually in cost accounting, you might not be, in fact, you will not be examined on the graphical method, but the algebraic method, which are the formulas for estimating the EOQ. The formulas that are associated with EOQ, so I call them mathematical approach. So if we are going to get our EOQ, economic order quantity, the formula is square root of 2 DOC over CC. In this case, D is annual demand. OC is the ordering cost per order. CC is carrying cost per unit. Now, there are ways we can also find some of these variables. This is EOQ. The second one, if we are going to find the ordering cost, the formula for the total ordering cost, TOC, is D over Q times OC. Remember, we have divided OC already here. So the next one that is new is TOC, that is total ordering cost. OC already is the ordering cost per order. D is the annual demand. Q in this case will now be our EOQ. Q is our EOQ. Then another thing we can find is total carrying cost. That's TCC. So we can say TCC is Q over 2 times CC. So we know what Q is, EOQ. CC is our carrying cost per unit. Then we have another formula. We can find the total purchase cost. Total purchase cost. Our total purchase cost is going to be D times P. Our D is still the annual demand. PP will now be the purchase price. PP is purchase price. That is the price of one unit. Then the last one we can look for is total. Okay, I'll give another one. Total relevant cost. Total relevant cost. Sometimes they call it the total controllable cost. Total relevant cost or total controllable cost. Total controllable cost. The total controllable cost. And to find this is just the addition of the two costs that are so relevant. That is the total ordering cost plus total carrying cost. That is D over Q times OC plus Q over 2 times CC. And the last formula to discuss is total material cost. The total cost of material. In this case, we are not looking at what is controllable or non-controllable. We are looking at the total amount of money the company is going to expend, and that is going to be the total purchase cost of buying the material, total cost of making the order, plus total cost of keeping the materials in the store. So that's going to be addition of this, and this as our total material cost. I think we should take an illustration to buttress all this formula. You should remember that some of this formula or none of this formula would be provided under examination condition. You are expected to know them. You may not have to cram them. Go over these video lectures as many times as possible for you to know, and as you are solving the question, I'm sure you would also be exposed to the formulas on and on. Now let's look at a question. We have a wholesaler wishes to establish the EOQ for calculator, which it buys from the manufacturer and sells to retailers, and has obtained the following information. The annual demand 80,000 units, that's our D. Holding cost per calculator, that is 50 kobo, that's our carrying cost. Remember, it's also known as holding cost. Delivery charge 30 naira per order, that's going to be our ordering cost. Now it is important to emphasize at this point that sometimes the carrying cost or holding cost, as is also known, may not be given in values. The examiner may provide this in percentage. So where carrying cost is given in percentage, it should be taken as a function of the purchase price. Carrying cost can be the function of the purchase price. So if we are given in percentage, you will look for the purchase price. So in this case, the question asks us to calculate the EOQ and the total annual relevant cost. Annual relevant cost. So we solve this question. Solution. The first thing we do is to find the EOQ. Remember, EOQ is square root of 2DOC over CC, and that's going to be square root of our annual demand 80,000, 2 times 80,000 times the ordering cost is given as 30 naira and the carrying cost is given as 50 kobo. So this will give us 2 times this is 60, 48, 480, that's 4,800,000 divided by 0.50. and that will give us the square root of, that's half of this times 2, that's 9,600,000. So, and we have 9,600,000. So if we're going to find the square root of 9,600,000, that's going to be, let's use our calculator, 9,600,000 square root. The square root of 9,600,000 will give us that's giving us 3,098 approximately 3,098, just to approximate. So if we're going to find the annual relevant cost, total annual relevant cost, so that's going to be the total carrying cost plus total ordering cost, and that's going to be Q divided by 2 times CC plus D divided by Q times OC. I'm using variables that are common and picked from some of the names, so we can be familiar with the formulas and what they relate to. Now our Q in this case is 3098 divided by 2, and our carrying cost is 50 kobo, plus our annual demand is 80,000 divided by 3098 times the ordering cost, which is 30. So this is going to give us, so here 3,098 divided by 2 times 0.50, that will give us 774.5 plus 80,000 divided by 3098 times 30, that's 774.7. So 774.5 plus 774.7, that will give us 1549.2. So that's our total relevant cost. Now, going over the question again, you should remember that if you're going to do your EOQ, you need to be able to identify your annual demand, ordering cost, and carrying cost. Once you are able to identify these variables, then you're good to go. Now, moving on, let's say another aspect. We have EOQ with discount. EOQ with discount. One of the basic assumptions is the absence of discount in purchase price. Usually, discount can be obtained when higher quantities are ordered, and when there is a discount, the relevant cost to be computed are the total ordering cost, total holding cost, and the total purchase price. The steps in solving discount questions are to determine the EOQ, determine the total relevant cost of the different discount levels, then pick the quantity with the lowest relevant cost as the EOQ. Now we are to assume the same annual demand, that's the 80,000 units in the question above, and the ordering cost, which is 30 naira in the above question, but that the purchase cost in this case is 100, and the discount of 10% will be granted if order size is increased to 4,000 units. The carrying cost is estimated at 5% of cost. should the order size be increased. So here our annual demand is 80,000. Our ordering cost is 30 naira. Our carrying cost will now be 5% of the purchase price. Remember, I told you it can be a function. That's going to be 5 naira. So that's 5% of 500 should give us 5 naira. 5 naira, not 50. 5 naira. Now, our EOQ will be square root of 2 DOC over CC, which is 2 times 30,000 times 30 over 5 naira. That's going to give us 2 times 80,000 times 30 divided by 5. It gives us 960,000. If we have our 960,000, the square root of 960,000, that's 979.8. Let's say approximately 980 units. So this is what the company is ordering. But we have been told that if the company can raise its order to 4,000 units, it will enjoy a 10% discount. So what we have to find is the total material cost. Total material cost. Now, we do without discount if discount is not taken, and if discount is taken. With discount, without discount. Now, what we are picking here, our annual demand, whether discount is accepted or not, remains 80,000. Our ordering cost will not be affected. That will be 30 naira, and this will be 30 naira. But the carrying purchase price, let me pick purchase price first. Currently purchase price is 100 naira without discount. But if the company accepts the discount, we are told that the company will enjoy 10% discount. So it means 10% will be taken off 100 naira. That's 100. Let me use a different color to do that. So using a different color, we'll have, let me use this. So it means the purchase price will now be 100. Okay, it's going to be 100 times 90%, meaning 10% has been taken off. That's going to be 90 naira. Then the carrying cost, which is the next thing we need to identify. The carrying cost, when there is no discount, the carrying cost is 5 naira. But now that the purchase price has changed, it means the carrying cost will now be 5% of 90 naira, which should be 4.5. So then demand, quantity rather. The quantity, if there is no discount, the company will order 980. But to enjoy the discount, the company must order 4,000 units. Then we can do our cost. Remember, I told you that our total material cost is going to be the total purchase cost, total carrying cost, total ordering cost. So what we'll do is our total purchase cost, that's going to be the annual demand times purchase price. So it's going to be annual demand 80 times purchase price 100. That should give us 8 million here. And for those with discount, we have 80 times 90. 80,000 times 90. Then total ordering cost. The total ordering cost will be annual demand divided by quantity times ordering cost per unit. So annual demand is 80,000 divided by EOQ 980 times ordering cost 30. That will give us 2449 approximately. Then we do the same thing for with discount. With discount now, 80,000 units will be demanded, divided by 4,000 units must be ordered to enjoy the discount, times 30. So we have 600. Then total carrying cost, which is Q divided by 2 times the carrying cost. Now the EOQ 680 here divided by 2, carrying cost is 5. We have 2450. And for this EOQ 4000 divided by 2 times 4.5, that's 9,000. So if we add up, we have 8 million and 4,809, 900 and okay. So this 899. Then here we have 7,209,600. So you will see that the material cost under the discount is lower than the material cost under the normal EOQ. So in this case, it will be advisable for the company to accept the discount. It's advisable to accept the discount. The company can take the discount. Now the next part of EOQ that we're looking at, don't forget we have 3 aspects of inventory control system: EOQ, reorder level, and just in time. So we're still battling with EOQ. The next one we're looking at is the EOQ with gradual replenishment. This is also known as production runs model. It is an inventory model in which stock are received from production line within the organization. That is, the manufacturer becomes the stock holder. It has the same characteristics as the basic EOQ model. The organization will replenish inventory levels gradually by manufacturing their own product internally. Also needs to calculate the most economic batch size to produce. So in this case, we will be calculating economic batch quantity with the formula square root of D into SC over CC into 1 minus D over R. SC in this case means setup cost, R means production runs. Now remember that the formula used to be DOC, but OC here is ordering cost. But since the company will now be producing internally on its own, it means that it no longer needs to order, but each time there is production or production is about to be made, it will have to set up facilities, machines and equipment for production. So only setup cost will be considered. The ordering cost will be ignored. We have a question. Titilope, as the name, or Lofe, whatever, Ventures uses components at the rate of 50 units per month, and which are bought in at the cost of 1 naira 20 kobo each from the supplier. It costs 20 naira each time to place an order, regardless of the order size. The holding cost per unit is 20% of the value of stock. The company has decided to make the raw materials in its own factory. The necessary machinery has been purchased, which has a capacity of 18,000 kg, and the cost of setting up each batch is 15 naira. So it means that in this question, our annual demand D is going to be 500 units that are used per month, and in each year we have 12 months. That's 6,000. Now, why am I multiplying by 12? Our D is annual demand, but we are giving monthly demand, so we need to convert it to a year. The next thing I need is the setup cost, which is given as 15 naira. Our production runs, facility can produce to be square root of 2DOSC over CC into 1 minus D over R. So I have 2 times 6,000 times 15, everything divided by 0.24 into 1 minus 6,000 over 18,000 by the formula. So that's giving us 2 times 6,000 times 15, that's 180,000. Then 0.24 into 1 minus 6,000 divided by 18,000 divided by 18,000, that's 0.3333 to approximate. So I'll have 180,000 divided by 1 minus 0.333 times 0.24, that is 0.16. That will give us, I decided to solve in steps, not jumping anything. So 180,000 divided by 0.16 will give us 1125,000. Then the square root of the answer, so that is 1060.66. So approximately 1061 unit. So the annual demand will be 1060 units. That is the number of units that would be produced per batch. Now, having said this, we have found the square root of the batch size. Then we can move to the next aspect of inventory control, which is reorder level. So that is the second aspect of inventory control. The reorder level is the stock control technique where levels are set to avoid overstocking or understocking. If the stock falls to the reorder level, an order will be placed for fixed quantity. The following are the major levels set by management. 1. Maximum level. This is the highest level which should not be exceeded so as to avoid overstocking. In setting up the maximum level, the following factors should be considered: availability of enough capital, storage space, the facility available. Then we need to look at the durability of the stock. How long can the items remain in the store? Reliability of the supplier. Can we rely on the supplier to give us materials as they are needed? The rate of demand. How often do customers request for supply of our materials? If we are able to understand this, then we can determine our maximum level. The formula for the maximum level is given as the reorder level plus EOQ minus minimum usage times minimum lead time. ROL reorder level EOQ. Lead time is the period between when an order is placed and when the supplier delivers. So the difference between the period you will make an order and the period delivery will be made. We have another one which is known as the minimum level. This is the level which the stock should not be allowed to fall below to avoid stock out. It is also called safety stock levels. The factors such as lead time, rate of demand, maximum level, etc. should be considered when setting the minimum level. So that means minimum is the least that can be held, maximum is the highest that can be held, and it is calculated as reorder level minus average usage times average lead time. Then we have the reorder level itself. The reorder level itself is calculated as. Now, talking about the reorder level, it is the stock level where new orders is placed before the minimum level is reached in order to avoid stock out. So it means that it is the level inventories will fall to, then the organization will place an order. So the difference between the time the order is placed and the time delivery will be reached will serve as the quantity that will be used. Let's say this is the maximum level, this is the minimum level, the reorder level should be set somewhere here. So this will be the consumption gap and this will be the delivery gap. So the reorder level is maximum usage times the maximum lead time. Then we have the average level. This is the addition of maximum level and the minimum level divided by 2. That is maximum level plus minimum level divided by 2. The stock turnover rate is another inventory control level, and it measures the number of times inventory is sold or used in a time period. It is given as total materials consumed divided by average stock level. Now, the next thing we have is the question. The following information relates to CR7 Construction Limited, whose annual metal demand was 10,000 units. Annual demand is 10,000 units. Stock carrying cost per naira is 40 kobo, while the purchase price is 5 naira per order. The ordering cost is 16 naira per order. It was observed that the usage range per week is between 150 and 250 units, and the lead time for suppliers is between 1 week and 3 weeks. Require calculate reorder level, minimum level, maximum level, and reorder quantity. So from what we have in this question, we have the annual demand, which is 10,000 units. We also have the carrying cost, which is 40 kobo. We have ordering cost, which is 16 naira. We have usage, which is 150 to 250, and we have lead time, which is 1 to 3. So we have been able to identify all the variables. Then we can calculate anything that is required to be calculated. So based on what we have, we can calculate our reorder level, which is, we are dealing with CR7 Construction Limited. So the other level is going to be the maximum quantity that is used multiplied by the maximum lead time. So the maximum usage is between 150, the higher of the two is 250, and delivery is 3 weeks. So that should give us 6 plus 1, 750 units. That's that, as simple as that. The next thing we'll calculate is to calculate the minimum level. Minimum level is given as the reorder level plus minus reorder level minus the average usage times average lead time. Now, based on the question, our reorder level is given as, or is derived as, 750 minus our average usage is going to be the maximum and minimum usage, which is 150 plus 250 divided by 2, plus average lead time 1 week plus 3 weeks divided by 2. So I have 750 minus 150 plus 250 is 400 divided by 2, that is 200, plus 1 plus 3 is 4 divided by 2, that is 2. So 750 minus 400, that will be 350 units. That's our minimum level. Then the next one is our maximum level. We cannot determine the maximum level without EOQ. So I would prefer to do the EOQ first. After the EOQ, then we can do the maximum level. So let's do our EOQ, economic order quantity. Economic order quantity. The economic order quantity is given as 2DOC into CC, and that's going to be 2 times our annual demand is 10,000 times ordering cost is 16, and the carrying cost we have 0.4. So this will give us square root of 2 times 10,000 times 16, that's 320,000, divided by we have carrying cost here to be 0. But I am just saying something here that we need to be careful with. We are told that the stock carrying cost per naira is 40 kobo. It is not 40 kobo, it is per naira. So that is equivalent to 40%. It's equivalent to 40%. So we've not gotten that right. We have to multiply with the purchase price. We have to multiply it with the purchase price. We need to multiply with the purchase price to calculate our carrying cost better. So it's going to be 0.4 times 5. 0.4 times 5, and that will give us 2. So square root of this will give us 160. Square root of 16 is 4. Square root of 100 is 10. Square root of 100 is 10. So that will give us 400 units. So we need to be careful with that. So it's not 40 kobo, it's 0.4 or 5 naira, because it's per naira. So for every 1 naira of the purchase price, the carrying cost will be 40 kobo. So when the purchase price is 5 naira, the carrying cost is going to be 2 naira. So now we can find our maximum stock level. Maximum stock level. So our maximum stock level will be the reorder level plus reorder quantity, that's our EOQ, minus minimum usage times minimum lead time. Minimum usage times minimum lead time. So what we have now is our reorder level is going to be, or is, 750 plus the reorder quantity is 400 minus minimum usage from the question 150, and the minimum lead time is 1 week. So I have 750 plus 400 minus 150. So this 600 plus this 1000. So that's going to be 1000 units. 1000 units is the maximum unit that can be in store. Minimum unit is 350 and the reorder level is 750. So when the number of units in store is 750 units, the company would request for replenishment, and if they are going to get supply, they are going to order 400 units, and they must ensure that the number of units in the store is not less than 350 units. So let's remind ourselves where we started from. We will start with the discussion of the inventory control levels, And under inventory control levels, we say we have the economic order quantity, the reorder level system, and just in time. So we have discussed the EOQ as a quantity that will minimize material cost, and we discussed the various assumptions, how to derive it graphically and mathematically, and various aspects of EOQ, both discount and gradual replenishment. Then we look at the reorder level. Now we need to discuss the just-in-time system in order to complete the aspect of the material system. Now, the just-in-time is a production and inventory control system in which materials are purchased and products are produced only as needed to meet actual customer demands. The just-in-time system was developed in Japan at Toyota. As the name suggests, just in time. It means that raw materials are received just in time to go into production. Manufacturing parts are completed just in time to be assembled into product, and products are completed just in time to be delivered to customers. Hence, just in time is divided into the just in time purchasing and just in time production. This will still discuss much more in depth when we move to one of the chapters in this course, but because it's one of the aspects of control levels, I don't want us to skip it. Now, advantage are that funds that were tied up in the inventories can be used elsewhere. Warehouse previously used to store inventories can be used for other more productive uses. Throughput time is reduced, resulting in greater potential output and quicker response to customers. Then defect rates are reduced, resulting in less waste and greater customer satisfaction. Then disadvantage is that it may be difficult and expensive to introduce. It opens businesses to a number of risks. Then a minor disruption in supplies from just one supplier could force production to cease, because you only buy materials when production is to start. So if materials are not delivered on time, then there may be a serious disruption of production activities. Then it may be very difficult and expensive to introduce. If you decide not to be having items in store when there is demand and items cannot be supplied as they are needed. So that is our material control system.